As University of Florida professor Tom Hodson explains it, industrial and systems engineering falls into the cracks between engineering, mathematics, and business. Engineering techniques and tools are used to solve the problems of business and management. Dr. Hodson explains why this has become so important.
Well, there's a couple of reasons. First of all, people are more and more concerned with profits and losses. But also, if you look at the gross national product of this country, it's been moving and will continue to move towards services. It's made up of the production of goods and the production of services. It's moving more and more towards services. And a service is just an operation, which needs management. And so in a service organization, the only kind of engineer you really need is an industrial and systems engineer.
A good example is this working model of an automated warehouse, which simulates a computer-operated stacking crane. Under Dr. Hodson's supervision, it was designed and built by students from surplus parts and junk. Students devise their own computer programs, and the automated warehouse proceeds to receive, store, retrieve, reorder, and inventory as provided by its computer instructions. Dr. Hodson says the principles learned here could go a long way to solving major economic problems.
One of our biggest problems is productivity. And when you're talking about productivity, then you're talking about automation, which is what this is. And you're talking about doing what you do efficiently, allocating resources efficiently. And that's what industrial and systems engineering is all about.
Dr. Hodson is also a professor who is practicing what he's teaching. He's presently designing an automation system for the Navy for use at its aviation repair facilities around the country. This is Warren Croak reporting from Gainesville.
It's the one way that we can improve our productivity in this country and make ourselves more competitive with the other nations. One looks at a lot of the other nations, they're Germany, Japan, the people who we're competing with who are doing better than we are. Okay. Or do a better job than we do nationally in terms of automation. To a certain extent, yes, but typically what happens is you've got higher paid people running the system, so in some sense you are putting people out of work, but as our economy expands, the only way we can expand our economy, the only way we can become more productive is to do things cheaper, okay? And if we can expand with the same number of people and do more work, then we'll get ahead as a country. Our problem is now that we're not expanding our productivity. And this is a means to expand our productivity and allow us to do more with the same number of people. Well, if one looks down the road and looks at Bureau of Labor statistics, forecasts, and things like that, industrial engineering, industrial and systems engineering is the fastest growing of the engineering disciplines. And we've seen that over about the last 7-8 years. And what we've seen over the last 7-8 years is a faster growth not only in the job market for industrial engineers, but also in starting salaries for industrial engineers. They've gone up much faster than the other engineering.